Not a very hard section, not a whole lot to it. Probably all things you've dealt with before. What do you think I mean when I draw that picture right there? What word do you think that means?
Triangles.
We classify triangles by their angles and sides. When we classify them by their angles, they're either acute, right, or obtuse. When it's an acute triangle, those of you that remember that have dealt with this before, what does it mean?
Lower than 90
Smaller
degrees.
than 90.
All angles are less than 90 degrees. And when we say all angles, we're talking about the vertex angles. Right.
90
All
degrees.
It has one
Or one.
90-degree angle. Obtuse has
Greater.
one angle greater than 90 degrees. The other way we classify them is by their sides. Scalene.
That's
Anybody?
None of the sides are equal.
No sides are, what's that word mean? What's that symbol mean?
Congruent.
Congruent. What's the other one?
Isosceles.
What was the other one?
Two sides are equal.
They have at least two sides congruent. Then we have equilateral,
Or all sides are congruent.
all sides are congruent. That's pretty easy, isn't it?
Yeah.
Okay. Only thing I want to talk about a little more. I might have done a better job drawing a picture of it than that. Everybody got this down? Hands are cold from the duty. Hard to write. They talk about isosceles triangles. Just the way we name some things. Okay? An isosceles triangle, you have your two sides that have to be congruent. These are called your legs. congruent sides. Okay, does that make sense? The angle where the legs meet is called the vertex angle. And the two angles at the bottom, opposite the vertex angle, are called your base angles. In isosceles triangles, base angles are always congruent. In any triangle, if the two sides are congruent, the two opposite angles are congruent. That's a theorem we'll get into later in the chapter. We're going to do an example now. Write that down. It says triangle ABC is an isosceles triangle. The vertex angle is angle A. Find X and AC. Write that down. Everyone got this written down? Any ideas how I might do this problem?
2x plus 4.
Now, first thing we're going to do, well, actually, better yet, what are the key words in the question? What do you say, D? What's the key words here in this question? Kind of tell you something about it. I say triangle ABC is a what? That's an important part right there. What does that tell me? Well, that it's going to have two sides congruent in it, right? That's all that tells me. I don't know which two sides, and just because it looks like it doesn't mean you can say that's the one. Okay? Now, the vertex angle is angle A. Do you think that's important? they say find X and AC. Now, they didn't tell me directly which two sides were congruent in this isosceles triangle, did they?
No.
Well, they did tell me what the vertex angle though is, and this is the vertex angle right here. Everyone agree?
Yes.
How does the vertex angle relate to the two sides that are congruent? It connects them, doesn't it? So that would mean that this side has to be congruent to what?
This side.
Which tells me what I need to do, doesn't it? Anytime it looks like an algebra problem, what do I probably need to create? An equation. What's equal here? Everyone agree? Can I find X now?
Yes.
I can solve and find X. Will that help me then find AC?
Yes.
Okay, so let's do that. I'm going to subtract 2x. Left with 4 is equal to x minus 10. What do I do now?
Add 10 to both sides.
So x is what?
Equals 14.
Well, I need to find AC. Find out what it is equal to. What is AC? AC is 3 times whatever what?
4.
X is, whatever x is, minus 10. And x in this case is 14. I don't want, what is 3 times 14? 42 minus 10, what is AC equal to? 32. Make sure you got that written down. Yes.
On AC, does it matter which equation you use? Like, can you also use 2x plus 4 to solve it when you do an AC?
Yes, you could. You should get the same, deal. And you do 20, you get 2 times 14, which is 28 plus 4 is 32. You should get the same either way. Just because in this case, they're what? Congruent. Yeah. That would be a way to check and see if you did it right too. Because if you got a different number, then something's wrong. You might have a problem like this. You're also going to have problems where they ask you to classify a triangle. I mean, that is the name of the section, correct? How would I classify this triangle? You guys see that? Need to make it bigger? Has everybody got the thing on top written down?
Yes.
Okay. This triangle right here, yes, it's an ugly triangle. I didn't do a good job of drawing it, but we're just going by the specs of what we see. How would I classify this triangle? Now, here's where I would classify them. In the same order I gave you the stuff. What did I give you first?
Angles.
You classify them by angles, and then by,
Sides.
so there should be 2 names there, shouldn't there? First of all, by the angles, how do I classify this?
Acute.
Okay, it's an obtuse. Well, no, I just went by what you guys said. Why, it's not obtuse, is it?
No, it's acute.
All the angles are what?
Less than 90.
So it's a what?
Acute.
Acute. Acute what?
Isosceles.
Isosceles. Acute isosceles. Easy enough, right? Classify this triangle.
Obtuse.
First, by the angles, it's obtuse. Obtuse scalene.
A right equilateral. No, acute equilateral. Acute equilateral.
Now, does anybody know another name that I can put with that one?
Yes.
What? It's actually also what?
Isosceles.
Because it says at least two.
At least two of them are congruent, right?
Yeah.
Now, do you necessarily need to put that?
No.
No, you don't.
It's equilateral.
Because equilateral is obviously isosceles, okay? So in the world of math, you know, it's understood that an equilateral is an isosceles triangle as well. Do you think it'd be possible to have an obtuse equilateral triangle?
Possible.
Yeah.
No.
No.
I don't think
No,
so.
I'm trying to picture it in my mind.
I don't think so.
Maybe.
We could try.
It's possible.
Anything possible.
Look at the angles. Can anybody tell me what all the angles and every one of the triangles I drew have in common?
They're all.
They're all triangles.
Okay.
Sure.
Okay, look at the angles there.
It's so
Okay?
funny.
Everybody see the angles?
Yes.
Look at the angles there.
We're all triangles.
Look at the angles. Look at the angle there.
They all have at least two angles.
All
that
the
is
angles
90.
almost look the same.
No.
Most
They all have three angles. They have really
there's two that's almost oh, they add up. No, I'm wrong. I'm not? They add up?
So
No.
one.
Add to 180.
These three add to 180. 90, 50, and 40.
You didn't even know you.
That's true, didn't I
105,
guess?
35, 40.
180.
46, 46, 88.
180.
All the angles inside a triangle have to add to.
180.
So you can't have more
So you
than
can't.
So you can't have, because there's no way to split 180 up evenly other than 60, 60, 60.
Oh, okay.
So it's always an acute what? Equilateral. And we'll get into more stuff later, but that's an important fact that we'll get into a little more in the future as well. Okay?